Oh no! Where am I? No camera. Let's fix that. We'll get it. Not that one. There we go. Welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. Yesterday we left on a cliffhanger. Some registers that we couldn't solve. I think I figured it out, but we'll have to see together. And then I think we're done with the bridge, except for one small thing on the PSP that I'm not going to worry about at the moment. Let me get my workspace going. So yesterday when we left, we had an issue with not the PlayStation Entity Bridge, which, besides not loading, was working fine. It was with the PSP bridge and also not loading. Oi, this was just working before I started. Of course, once I start capturing, that's when it stops working. Let's get that loaded. Oh, there we go. So here's the PlayStation version. The PlayStation version is fine. And do I want to integrate this yet? I don't think so. Let's get the PSP version working. I'll show you what was going on. So on the PSP version, there we go. We were having register issues down here on line 97, and we don't have a lot of hints or tells as to what might be going on. We're getting some of those misallocated registers on this function call and previously on pose timer. We're using register V0 on ours versus V1, which may or may not suggest something. And often when we have register issues, the most common thing that I've seen is it comes down to the comparison operator being used. And so something like this pose greater than 3 might actually be equal to greater than equal 4. And we see that we do get register changes when that happens, moving from at to V1. Usually that's what it is, at to V1. But A0, V0, those are a little trickier. We know that we're going to need the A0 register for Break Bridge. But it's being used and it's being clobbered fine. No issue there. There's not really a lot else. I did try changing this to an explicit equality check. So instead of a not doing a equals 0, you get some, because this is a sine 16, you have to do the sine extension to get that working correctly. So that's not it either. We're kind of limited. There's a handful, and on the Soten Decomp wiki, you go to GitHub. If my computer would load. You can go to the wiki here and go to more pages. Register mismatch. Hey, Romy, good to have you. And this will actually go through, and it talks about the greater than equals. That's a reasonably common one. Some mod tricks. The mod tricks, usually if I see random hex values, you know it's a division or a mod. And those I think are pretty obvious. The move one is a little interesting, but that doesn't affect us. And this is it here. The static function declaration. But it's more than just static function declaration. It is having the function fully declared. Well, I guess that is it's not declaration, it's static function definition. And I should update the wiki to use the right terminology. So if we go up, and this is the PSP version, so the function that we're calling in this section is break bridge. And so we're going to go up, and this is going to screw up our RO data, but that's fine. We're going to add a static definition for that. Break bridge returns a void, takes an int, and we're not going to actually do anything. We're just going to leave it empty. And that's enough that we do get the code for that up above. Nothing we can do about that, really. That's just the way decomp.me works, but we have to ignore it. And then also ignore the RO data, which is off, but going back then and looking at our registers. Where were we? Down here at Breakbridge 102. We're all fine. All the registers work out. So I think that's what the issue is. Fortunately, we have that already in both of these files. I'm going to go to the PSP version first. And we can mark this static, and I think that will be fine, because I don't think anything else outside of this function will use this. Yep, that's fine. And just to keep it in sync, PSP, we'll do the same thing for PlayStation. I do want to see what the difference is. I think there's one global reference that differs between the two files. Oh, and we have this other function as well. Yeah, so we have this global reference. We'll have to map that, a comment there where the header is, and then where the paths are for these things. So I think we're doing okay. What I'm going to do is go over to the background piece file. I'm going to make those the same. So if def version PSP, we're going to include this. Otherwise, we're going to use our breakable bridge. That should work fine. And I'll take that over. Or sorry, background bridge piece was that function. That should still work fine. And if we do the diff now, I was on the wrong side. We only get those. The one global that differs. We have a lot more globals that we have to deal with this trigger function. But let's see, what can we do? Should we map those globals? Should we import the data? We got a lot of choices here. We have an init that we probably should give a symbol to. This one here. This Boolean actually is something else. This is in main. Kilocan. Appreciate it. Toilet Pain, welcome to the channel. Appreciate the sub. Always appreciated. Gotta keep it motivated. So we're gonna, let's see, we're gonna import this, but we need to figure out the symbols first. So let's figure out what the 72F20 is. It's part of like the main or DRA allocation. So it's going to be in the base symbol table. And it's somewhere around graphics load. Let's see what that struct looks like. Sorry, forgot the symbol offset already. No, so it's after that. let's see where that symbol is to find. If it is yet, it might not be. Interesting to find a new like base global symbol that hasn't been used before. Not in source. Interesting. We do have a reference to it though. Several. BO4 is completely decompiled. Oh, no, it's not. No, it's not. So this is something in ST Common. So it must be something that we've seen before. Let's look at that ST Common function. Oh, thank you, Killican. Appreciate the kind words. I enjoy PS1 and Symphony of the Night as well. I do have an odd history with the PS1. I had a PS1. I was very interested in it, and then I kind of fell away from video games for a while. But then later, not super late, still in the 90s, I picked up a PS1. But I sold my entire Genesis collection to get it. And looking back, I regret that, and I have some disdain, is that the right word, for the PS1 because of it. PS1 didn't do anything wrong. All right, so what? Let's do this. The symbol is being auto-generated, but we should be able to see what symbol is coming right before it. Oh, so it's part of G player. That makes more sense. Let's look at G player. G player actually is somewhat nice because it actually lists the offsets of all of these things. So we're looking for 7.2. Oh, those aren't the right addresses at all. 2007.2. Player state. I'm at the wrong place. 7.2 F20. VRAM flag. So why didn't VRAM flag? Why don't we have a symbol for that? We will soon. Strange. I'm pretty sure we used to. There's some pluses and minuses to doing this. SPIM can't deal with symbols that appear within the span of another symbol. So we said that this G player symbol is 3 CE in length, but then we declared two symbols that are overlapping with that range. And SPIM just throws its hands up and doesn't do anything. Actually, it will declare these, but it won't assign offsets for G player that come before those. And that's a bummer. I've mentioned before, a segment tree would solve that. So a segment tree allows you to map exactly this scenario where you have different segments, and within those segments, you can have smaller segments. The minimal address, addressable memory is a multiple of 4. So we know that demo timer and VRAM flag, for example, have sizes, and that size is 4. That's just the implicit size of those. So those fit within the segment tree model. Well, anyway, we know what this is. We can go back and fix that. That's good. That's one more out of the way. The name VRAM flag comes from some debug printing. It's not really indicative of what it does, though. All right, what else do we need? So we have an EINIT here. The EINIT is the bridge break trigger, so that one we will add a symbol for first. So this is PSPEU STNZ1. And we'll call this GE init bridge break trigger. And so then on the other side, we come through. And grab that address. Let me just check my phone in a second. Oh, interesting. It's already EINIT environment on this side. So let's check to see if we have that symbol. We do, but it's different. No, it's the same. I must have created the scratch before getting that symbol. So, okay. Fix that on both sides. And then the remaining values may be things that we can bring in as data. So let's look at those. I think this is all in EDC, and that's where this starts. So the start of this data file is going to be for breakable bridge. We go to F20, actually past that, including all of these things, and then we don't have F44, and let's see where F44 starts. And look in the non-matchings. Actually, nothing references that directly. It's referenced here. And that's part of E-explosion. So let's take this. Open the splat config. And we're going to have to do this on both the PSP and the PS1. So give me a second while I get all that done. So data here is going to start at E breakable bridge. And then we're going to, I'm not going to put in the opaque puff. Segment yet, because I don't know specifically where it ends. And so if it ends in the middle and I've allocated it different ways, it'll confuse me later. All right, so let's grab STNZ1 data. And this is going to be a little different. So this data is showing up here. What's the best way to do this? Let's look for the PSP symbol. The first symbol is going to be here, 37. We'll grab that one. So at this 4. Ooh. We can't grab that one. So this is a flag, and this is interesting. It's definitely worth noting. It's a difference between how the PSP works and how the PlayStation works. Not how the systems work, but how the compilers work. GCC and MetroWorks. On GCC, if you set a variable or a global equal to 0, you're setting the value, and GCC will treat that as data. If you're setting it to 0 and MetroWorks sees it, it says that's the same as uninitialized data, which is also 0. And so I'm going to put that in BSS. In BSS, I don't have to actually write to the file. I don't have to allocate it. And so you get into kind of an interesting situation where there is actually no BSS file, or no data for that BSS, sorry, jumping around, on the PSP, but there is on the PlayStation. So what am I going to do? Since we're on the PlayStation now, let's take this and we'll deal with this data first, and then we'll go to the PlayStation, or PSP, sorry. And we'll do the same thing with the C files. Just kind of diff them as things are going. But once this data is imported, I don't have to worry about the symbol names anymore, because I'm fairly certain that this is not used outside. And we can mark all these things static, and that will guarantee that that's true. So we have our flag, which is 0. DEE0. It's a signed 16 array. SPIM didn't figure that out, so it's treating it as signed 32. So we have to remember that this is little endian short 16s being represented as little endian signed 32s. And I'm just going to look at that. Let's see. So this is like an array of colliders, and within the context of this function where it's used, we don't have enough information to know what the type is, and that's why SPIM did what it did. I'm gonna find that collision function where it's used. One second. I want to see what the signature is there, and then we can make sure that we get the right type. Takes an S16, yeah, and returns an int. So we're gonna have an S16. And like I said, we have to, this is probably the easier thing to grab, but we still have to switch the order of each of these. And I think this will be right. We'll find out. Make this an array. And then we have this EF0. EF0 is not used here. Oh, I'm doing this on the PSP. Pardon my mistake. It's used for... How far down are we? Through 24. So this is used in Break Bridge, and we know it's a sine 16, and we know basically it's in multiples of 4. I did try to make this a set of quads, but I couldn't get that to compile correctly, so I'm going to leave it like this. Sine 16 arrays are extremely common, and manually managing what the stride is also relatively common. I should say common in this game. Not common outside of this. So I'm gonna take these. I'm probably gonna turn Clang formatting off and put them in groups of 4. Oops, missed the last one. Because that makes sense to me. It's possible that this is something else that I am not recognizing. Usually in a code review, there's structs and things like that that I don't always catch. And so if this is a better type, hopefully that will. Caught. And then we have this position rotation structure. And so we're gonna have to take triples from this. Oh, I'm in the wrong place. F10. Oh, we have 0.16s first. Sorry. Static 0.16. Depending on the type, I'll come back and either format these or change them to decimal. Let's do this. Probably could have gotten rid of the new line first. It's okay. All right, and now we have that triple struct. So basically the same thing here, except we're going to take 3 values at a time. did too much. The way that these get packed, this one's going to be extra down here. It probably would be fine to just make them an array, but since they're declared in the same, or defined in the same file that they're used and they're static, getting the right type makes the most sense. This is going to be a negative value. I think having the hex. What am I doing? I'm not doing triples. I think having the hex values will be fine. But in case they're not, we may have to switch those, and we'll see soon enough. Alright, so we have all the data, and we don't have the trigger function in yet, but I'm going to test the data first. So we have our breakable bridge. We're going to change this to a dot data. And I hope that this works. Oh, I touched the symbols file, which is always a bad idea. Everything needs to get rebuilt, but that's okay. So we have an undefined reference to F24 that may be that's because there's assembly that depends on it and marks static, so the link, the linker can't link across those things. So we'll add the symbol here, and that will be enough. It should be. It's unnecessary. Oh, drat. Wrong place. Wrong place. I need to add this too. Yep, I have it open yet. The stage specific one. Oh, let's build everything again. So now what we've done is hopefully gone through and defined all of these globals. Looks like a syntax error. Putting an equal sign. Looks like we have one more of these. So if I screwed up the data at all, or the endianness, or anything like that, there may be an issue. One more? No, that one's there. Find reference to F28. We're not going to need this reference soon, and so maybe I should have done this the other way. We do have a symbol for it. I'm not sure why. Oh, I know why. Because this isn't getting rebuilt. We're gonna touch. There's kind of a circular dependency between the splat config and the C files. Splat generates the C files, and when things change, all the C files need to be generated, but sometimes when C files change, you need to run Splat again. Mostly that's with include ASM. I'm going to stop dealing with that at the moment and grab this break trigger function. And then we don't have to deal with the symbols anymore. Okay, we need init environment declared. EID 17. We don't have that either. So we have all of the entity IDs, but we don't have numbers for them. That's sad. So 17 is going to be 16 plus, so it's 21. Does this look like a 21? I think it is. So instead of EID 17, we're going to use eBridge trigger. All right, and so we do have a small difference here. So I was off by one. Puff Opage. And I'm hoping that those symbols are updated, or we have the IDs for them, but we might not. So here I'm going to replace EID 17 with that. Puff. Go back over here. And so we're building fine. So we mapped all the data, great. And the function is working as expected, also great. And so now the next step is to get that data mapped on the PSP and then basically do the same thing. So I'm gonna do this. We don't need those anymore. Shoot, I wanted the NZ1 header. Drat. So I need to go and get the EID macros set up. So the reason we need a macro for this is that the PSP version uses globals to define what the entity IDs are, and the PlayStation version uses constants. It's not clear to me why, but that is what happens. And so we have to play by the rules of the game. And so we usually set up an EID macro with all of the appropriate mappings for the PSP entity IDs. This looks like NP3 is set up correctly. we don't have anything there. Somewhere there is a oh, these all must just be in the symbol table. No. How do these mappings work? Ugh, I never remember how this works. It's a good system, and I should internalize it, but I don't. I don't know. Let's see, update. Is in include common. Include game. Include entity. Include stage, probably. Yeah, so there should be D_PSP E variables. And there are. Okay, so we have to go define those. Maybe they are defined already. No, they're not. Okay, DPSP E. And we're looking for explosion page. And we get the address for that from call to create entity here. 155. Oh, I actually have it up here already. And I think that's all that's necessary. So we can check EID should work correctly here. So I think everything will still build fine. And I touched that symbol table again, so apologies. Doppelganger, there's a few things for Doppelganger that still need to be done. I was going to say I should be able to get rid of that Doppelganger overlap. Doppelganger 40 needs its data mapped still. So that shouldn't affect that. All the code for Doppelganger 40 is done. It just needs data. Okay, so this worked fine. And now that symbol is mapped, so that should work fine as well. We will need an extern for that symbol. I actually like putting that in the NZ1 header. And we actually need one for each of these. But for now, puff is enough. Okay, so we have that. We have all the data. And that's what we were doing. We were mapping data. Let's get back to that. PSP-EU, SC-NZ1. Look at all the things. So it's not just about decompiling, but really what is the structure of that file and how do you deal with all of the other stuff that goes along with that. So we're going to find, again, that flag. It was EDC on the PlayStation. It's over on line 37. So that's 281468. Let's grab the whole thing. And we need to see where that is. And it's here at this 49B88. Way down here. So it's actually nearly at the bottom. But we will have to create a new BSS. I don't necessarily like how this is being done, but I don't have a good alternative either. The PSP files, the overlay files don't have the BSS data in them. So this 49B00 is actually the end of the file. And everything after that is something else. And so we don't get offsets here, so we have to calculate the offset ourselves. Bummer. Bummer. Come on, calculator. You can come over. Yeah, there you go. So we're going to take... Let's see if I can... Get a calculator up there. There we go. Let's make it a little bigger. We're going to take the address that we have here for our BSS. We're going to subtract the address for BSS start. And that gives us our offset 2E8. But that's not enough. We have to add that to the offset in the file. So that is where this split starts. And we're going to make it just not coming from the file quite yet. All right, so that's the BSS. Oh, we got to do a little more than that. This next value is not part of this, so we need to give it its own segment as well. So this one is going to be at 49D F0. No semicolons. So that's the BSS. Next is the data. And our first data is at EE0. Sorry, EE0 is the PlayStation variable. PSP, we have this one. And so we should see basically the same layout here. Where we have... Hey, ThinkPat, good to see ya. Appreciate you joining live. So on the PlayStation version of this breakable bridge, we have these values starting here with the 0, 1604, -4. I'm not going to touch those yet. So we want to make sure that what we're looking at looks the same on the PSP, and it does. So this is where E-breakable bridge is going to start for the PSP. And I like, sometimes I don't do this carefully, but I do like to do it carefully when I am thinking about it. And kind of go step by step, do the split, make sure everything works. Come back, move the data over, see if that works. Keep it separated between PSP and PlayStation for as long as possible, and then finally switch over the file to be the same shared file. One interesting thing here is we're not guaranteed any ordering of the files between the two, and so on the PlayStation, E-breakable comes before E-breakable bridge, and on the PSP it's the opposite. I think there's one of the theories is the files are in alphabetical order. We don't know that for sure though, and if they were in alphabetical order, that would give us some hints as to what they might be named if there's question. So here we need to go down to, I'm guessing it's going to be the rest of this file, but we'll see. We have our triples, so we should see the triples getting broken up, but I don't see them. Rat. And the triples are the last thing in here, and that's going to be equivalent to Sun 48, which is this 820. And that happens to be where I am. Don't know why Spin didn't detect that. Oh, the cut Y. Oh, this is different too. I missed this. This is mapped already on the PlayStation. This is RO data on PlayStation, but just regular data on the PSP. But all this gets to come over too. That's all part of that function. And unfortunately, this is part of a function that I couldn't get matching on the PSP. But it should all be fine. What we're going to have to do to support that is we're actually going to create a second E-breakable bridge data segment, and we're going to start the second one at this string, because the string I don't have code for, and we're not going to be able to get it. So then we're going to come back over, and depending on whether that symbol file needs this data is going to change what we do, but we'll burn that bridge when we get to it. We're going to take all of this data, drop it in the PSP version. The only thing that we need to worry about is this here, because that name is going to change now. And we can use the PlayStation name since that is what got moved over. Okay. So now all the data is in the file. We have to go back to the splat config and tell it that. So we put a dot in front of the type. So we have regular data, and then we have the BSS. No RO data here. RO data on MetroWorks is just symbol tables. We're going to build. I'm pretty sure I screwed something up, but we'll see. Yep. So we have undefined reference. So these are going to have to be mapped. So we have to go figure out what those were and map them to the new PlayStation names. Oh, entity bridge. The whole reason for doing this was so that I didn't have to map them for entity bridge break trigger, and that's what we're doing anyway. So let's go grab that. And I think this one is fine. What are the chances that Konami puts this on Steam? It's odd to me that it's not, honestly. I can't. There's one reason I can think, and it has to do with licensing, but that somewhat falls down when you consider that it's on mobile. Okay, so we have some chunks here that are different. Let me make sure that this so there's a couple things that could be happening. I might have screwed up my data. There could be an instruction that's off. Could be data that's off, that's shifting everything. Let's see if we can tell from this. We'll have to go see what 1C990 is. If it's in this area, that should be fine. It's possible that it is just a static address here. What is our, so AB versus AC. The next pair of lines, 3.4 versus 3.5. So we're off by 1 byte. One byte doesn't make sense, but we're off by, oh, I guess if this is little endian, it could be off by 16 bytes. That makes more sense. Let's see where this is. So my theory about why Konami hasn't done this, and it seems like it would be surmountable, and it seems like also that there'd be money to be made in it. But it has to do with licensing, not the game itself, but licensing with Sony. And this is all speculation and guessing, but my guess is that Sony does not see phones as a competitor to the PS5, but they do see PCs as a competitor. Okay, so what are we doing here? This is the first load, half unsigned. So what does that have to do with anything? Why? Who cares what Sony thinks? Let Konami do what they want to do. What's this switch? It has to do with the RO data. Yeah, they are. Okay, so the kind of backing up on the PSP, sorry, on the PlayStation 4, when the Requiem collection was released, to the best of my knowledge, it's using Sony's PSP emulation framework for the PlayStation 4. And my guess, and again, it's speculation and a guess, if you agreed, like as part of the terms of using Sony emulation technologies, you cannot publish that on the PC as well. For mobile, they did not use Sony's PSP emulator. They use a different PSP emulator. So they have a version of the game with a PSP emulator that's not owned by Sony. The only thing I can think of, so I mean, it's portable. With some tricks, you can at least start the game, the iOS version, on Mac OS. It doesn't work, but you can start the game. You can get to the license screen at least. All right, so what I want to see is this LHU. There's no other reason in my mind that that they wouldn't do that. So it's this here. We're loading offset 2C for A0. So this is the step. And I grabbed the offset, but that's not exactly where it is. So we're at 9C. And it is the it's where this is jumping to. So it's localized to this function, which is nice. There must be padding at the end that saves us from the entire function getting destroyed. So let's go down a little further and see 1CF90 looks like where the bulk of the difference comes in. 801C1. So we have 1C here versus 1D here. Again, that might be a jump. And yeah, we have a no-op that's getting put in here at 1D07C. That doesn't exist in the other one. So 1D07. And so that that is causing everything to be shifted down by one instruction. And I think we happen to catch something that aligns back. So let's go back here. Actually 1D070. Let's make sure that that difference doesn't exist. 1D7. And what I'm going to do actually, let's do this. Back here, let's get rid of this. What I'm worried about is that there's a no-op that's either getting added or maybe a branch is not going to the correct place. Let's see it, obviously. Let's do this again. 1D07. Okay, so this is the end of the function, and we have a no-op. And so this is saying that there is no no-op that's getting generated. No, we have an extra no-op that's getting generated. So this is interesting. It is possible, it's unlikely but possible, that our breakable bridge here actually starts at, no, not here, in the text section. Are we off? We have to be a multiple of 8. So what is causing this? So we're looking basically at the last instruction, and I see. So this is our jump register RA instruction. That is what you'll see at the end of every MIPS instruction, or every MIPS function. Then we have this 27BD. Basically, we have to walk this back until we find something that differs, because everything is offset by 1. And so we know at the start, it's the same. And so somewhere in here is going to be a missing pad. And it looks like it's right here. So we have a no-op here at 1C FB8, sorry, 1C FB8. We don't have that equivalent here. And so what's causing that? Let's find out. 1C FB8. Oh no, where's my function there? 1C FB8. This is our call to create entity. It has a no-op following it, and then our version does not. Create entity from entity. Let me make sure that I know what I did. This needs to be an EID. Boy. We should have this identifier. Did I not save this in the header file? Don't have the header file open. Hey, Nate, good to have you back. I am proud of you. Good job. I spent last week drinking more than I have in a while. Not for any particular reason, just because sometimes drinking is fun. Not a lot either, just a drink. I drink like, I don't know, maybe twice a month. I have one drink. And got some moonshine. Decided to have a few more than normal. Just one a night still, just more frequently. All right, so we have the EID here. Is it upset that it's not? I see the identifier is not defined. Not defined identifier means that there we go. And now we're matching again. So we got this matching. All right. Yeah, I would like to see that arbitrary code. You think you'll post it in the next couple days? Because we could talk about it next week. It would be neat to see where the overflows are, if we could figure that out. Oh, awesome. Okay, so we have this now. It's building. The identifier was the issue. So let's do a diff of this with the PlayStation version. Make sure that they're in line. So we have one unnecessary extern on the PlayStation version. Another unnecessary extern. Yep. That was it. All right, so the only difference between the two is the header that's being pulled in, because the PlayStation code is in the same directory as the header, so we don't have to go up a directory to get there. And then I have a comment in there about how a function is going to be dead stripped, which is actually more relevant to the PSP anyway. For kicks, I could put that comment in here, but it's gonna, this file's gonna get deleted soon anyway. And now we'll go get our splat on. So all the breakable bridge stuff now is just going to go to the PlayStation version instead of the PSP version. We're going to keep this in the PSP. That makes sense. Now let's move that over too. There is one function still that's not quite. And that should be fine. Thank you for the link. Uh-oh. Broke something real good. I'm gonna undo this, try again. I don't know what that... Internal error. What type of system gives me E340 errors? I'm gonna make sure all that is done. Yeah, all that's, let's, I guess, clean. And while we're cleaning, let's check out Nate's video.
Got red bottoms, but they orange. She want that lean, do it as the boys be boring. But when she want me in the morning, keep it chainsaw and stack in my storage. My style ain't got no father like an orb. Get your eyes, see you smile, but I don't feel like you. See the buildings, they fall. It's all for her. Pledge allegiance to myself, no. It's all I'll do. She's standing in the hallway. I use this in phone. So much drama like Broadway. It can't sell.
Like the bass.
But they all say, make her sleep in my heart breaks. I will take care of her. 30 times, 30 ounce, I won't peek at you. Moving slow, my coat came from Peru. Yellow, black bracelet, look like Pikachu. Stone cold, my Stone Island posted on the roof.
It's a lot of inventory. Much later? Not yet.
We can go anywhere to explore. My boss burning trees like the forest.
get into the inventory management. If I am missing something by skipping ahead, then
They're all wrong. Nobody wants to give, but they're all for talk. Nobody gives a fuck. I'm not the one to talk. Nobody gives a fuck. I'm not the one to talk. Baby blue plastic, wrap me around, exploding like fragments onto the ground. Wanna be like magic, burning not found. I exposed myself.
there's the clipping bed.
I'm done.
Is the purpose of that, I'm guessing, is just to get to the save as quickly as possible. And so the inventory, my guess is that the inventory modifications are there to seed the RNG. So we've lost color in the background. We're dumping text. And so now a bunch of these rights are going. Just a little bit, unless people, well, you have the link, you can watch it yourself. Ham line and line eggs.
I want the money, I don't care about this. In the night, there's no faces. Smirnoff Ice in the park, your lips. I'm walking around in the Matrix. Stockholm syndrome, they fell in love with the kid. Love the way you keep it safe, yeah. I've seen so many souls lost in a wind.
So ultimately, what's going to happen is through inventory management, we're writing MIPS instructions and then getting to execute those MIPS instructions. And so, what this ends up doing? Too much music. Sorry. It's writing a program to go through and set the end state trigger, and then jumps to that program. But because it's writing MIPS code through inventory management, technically you can write whatever you want. You could write SOTN in SOTN. But from a speedrunning perspective, obviously getting to the end game in 9 minutes, I think the world record currently is in the maybe 11-12 minutes. So this is 2 minutes faster than record. And that is also a glitched run. Not tool assisted. Very cool though. Very cool. Appreciate it, Nate. Well, look at this. I botched something in such a way that I'm getting an error that I've never seen before. Let's where was I when I did this? And what did I do? We should have RO data as well. No, apparently there's no RO data associated with this. let's get this back to something working. All right. So this is working. What I'm going to do, and what I like to do when I've screwed something up, and am not sure what that was, now I take the time to add everything relevant so that I can get back to this place when I need to. That one isn't important. All right. And I don't have anything in this branch yet. So I'll commit it even. And now I'm going to go back and try to figure out what was happening. So we have our PS1 on the left is the PS1 file that's being compiled for PS1. On the right is the PSP version. They're, for all intents and purposes, identical. The include path at the top is different, and there's a comment in the PlayStation 1 that I want to keep because it's actually relevant to the PSP. So what I would expect to do, and what I normally would do, is I'd go here and start changing the path to the PlayStation path. And we see other things in NZ1 here. Basically, any of the code that's already shared between the two versions of the game will be in and this may be what the issue is. I'm going to keep this NZ1 PSP. There are some issues with Splat when you have data files that are named the same thing and how that works. I'm going to keep that separated for now. All right, and let's try it again. This isn't like terribly all right, that worked. That worked fine. So what this gives us then is the ability to get rid of this PSP specific C file. And when we build for PSP now, it still works. And just show that it wasn't a fluke, we're going to get rid of all of the objects here. Oh, where's PSPU? Get rid of all those. So there's nothing that's been pre-built. Everything's going to have to be rebuilt. None of those objects were gone. So we got it. So there's one file now that's being shared between the PSP and the PlayStation. That's where I wanted to get to. Oh, and I can put my music back on. Oh, right. Thank you. Nate posted a link as well to the explanation. So I think I'll read through this over the weekend and then come back next week, and I'll wait for you to come in the chat and we'll talk about it. I think that's a good plan. You don't know what people look like necessarily in chat, but I've always assumed that Nate is a good-looking fellow. Same to all of you in the chat. Not that Sulaco guy, though. So the only difference currently between the PSP version and the PlayStation version is that on the PSP version, we're still using the assembly for this entity bridge background piece. And it's going to remain that way until somebody figures out what the difference in alignment between that is on the PSP and the PlayStation. So let's go look at... Whoa, what did we do? What is this? So we've been working on the breakable bridge in the clock tower. And we have a bunch of them. So it's... I don't know if bridge is the right term. Oh, there we go. There's one of them. Let's go see the pieces that are left over. So this is the bridge once it's been broken. The trigger function that we were just working on is when Skull Lord destroys me. That's when we actually touch the bridge from the top, when there's a collision from the top of the bridge. I have you beat, Skull Lord. I want to get to the bigger one. So any of these bridges are the same, even though there are multiple versions of it. And so we know where the code is. We could make some changes by finding different things like the rotation. We change the value of the rotation. That actually might be interesting. Take that, Harpy. But we'll save that for another day. I'm gonna leave it here. So thanks for watching. This is Made Up of Wires. We're decompiling Castlevania Symphony of the Night. I appreciate Nate giving us his arbitrary code execution, and we'll talk about that next week. And I'll try to get all this code that I mangled together, cleaned up, and submitted, and up into GitHub where you can find it later on. That's all I got. Adios.